So Muzaffar, you are able to see my screen, so I have to write again here that we
Yeah.
okay.
Alright.
So this is a RAM. So Muzaffar, the RAM is actually organized in a way that every place in the memory have an address, and typically the address is in number. For simplicity, I would say this is the first place, this is the second place, and this is the third place, and so on. Okay, and but we as a human, we cannot really remember too much of numbers. So if you have a program that you where you want to store maybe 1,000 places in the memory, how can you recognize and remember, oh, the place 100 contains what information, or the place 2,000 or 1,000 contain what information? It's very hard for our memory to recall that information. So that's why a new programming language actually allow us to use labels. So we are able to label a place of a memory and call it X or even Y, or even come here and say this is sum. So it means that we are able to no, for us, no need for us to remember the address, the real address of the memory, but internally the computer actually relates your label or your variable name in this case with the address number of the memory. So when I say X equal 200, Python automatically go to the memory and reserve a place and call it X for me. And then it will also store internally. And this is not interesting to us, but just a concept to understand. So
Okay.
X is related to a certain address that we ourselves will not know and we don't need to know. But it is just for our knowledge. Can you follow up me?
Yeah.
So in this case, if I tell him reserve a place called X, it will come to this 200 and store 200 inside the place of the memory that I call it X. Is that
Okay.
clear? Okay.
Yeah. Okay.
So, okay, I would say here, let me try to modify here and say X value equal, and then I put X like that. So what I'm trying to do on that line, I am telling the computer, please print a line that contains two parts. One part here is just kind of text, fixed text, just print it as it is. And this part is a dynamic part. So you have to go to the memory and search inside the memory. This is dynamic. So it will go to the memory, check is there is a place in the memory called X. If there is, it will bring the value that is stored in X, which is 200 in this case, and it will put it here and print whatever inside X. So let us have a look how it looks like when we run. So if I run like that, can you see what it prints to the screen? X value equal. It doesn't print X, it brings the value inside X.
Inside X. Okay.
Does this make sense to you?
Yeah.
Okay. Yeah. So we try to go a little bit deeper. So anything between double quotation is a text that it will treat it exactly, how to say, exactly the same it is you put it. So you put here rubbish, you find that in between double quotation, the computer is dumb. He doesn't understand what you write. So he will print it out exactly the same as long as it is between double quotation. Okay. So the computer is as smart as you as a programmer. If you are not smart programmer, also the computer will behave not as smart as you program it. Okay. Is that clear to you?
Okay. Understood. Yeah.
Perfect. So let me I took you a little bit fast. Let us try to recap a bit. Let me start here. Okay. So I would like to. So I don't want to assume the role that you want to use in your future when you are learning programming, but I will teach you the knowledge, and it depends. So if you work as a freelancer, big chance that you will not work with other programmers. But if you work
Okay.
in a company, then big chance that what I'm teaching you here will help you a bit. Okay, so
Okay.
one common concept that I have, it's common in international companies and especially outside Malaysia. We use a concept called pair programming. So I don't think that China-made companies inside Malaysia. I'm so sorry to say that. I mean, there is no harm. I mean, I don't mean anything bad about them, but this is even how
Okay.
the local Chinese say it. They call it China-made companies. So pair programming will not be understood in China-made companies. This is only in international setup. So pair programming is meant to say what? When a programmer sit down to write the code to solve a problem, they sit down in pairs. Pairs mean
Okay.
two programmers sitting together to write the code, not in using two computers, but actually using one computer. Okay, and they have two roles. One role we call it a driver, and this driver is a person who is writing on controlling the keyboard and writing the code. And we have another role that called navigator. So the navigator is a person who think and guide the driver to write the correct code and highlight to him issues that he might face. So that concept, if you watch rallies where two person are always sitting in the car, one holding the maps and managing the navigation, and another one is driving the car. So normally the person who is driving the car, they make him focus only on really controlling the car as good as he can, and the one sitting beside him, he's always the one who giving him direction. Turn right, turn left, careful, you are having maybe a hole in front of you, you need to maybe side right or side left. So you see, there is one driver. He doesn't
Yeah.
care about the map. He doesn't really look at the map or see where he's going. He's just following the instruction from the navigator. So that totally happened. The person who is controlling the keyboard is, we call him the driver. The person who is guiding him, we call him the navigator. And they take alternate roles. Means 1 or 2 days, maybe Tom will be the driver. Uh,
Yeah. They
Another
swap.
2 days, Aisha will be the driver, and so on. Okay, is that clear?
Okay. Yeah. Yeah.
Okay, so pair programming is actually common, and they say, I mean, the benefit of that. To be frank, I have done it a little in my working career, because most of the time we work in a very low capacity of programmers. We only a few programmers, less than maybe 8 or 9. So typically everybody have his own project, and we typically don't sit in pairs. Okay, uh,
Okay.
it's only a rare environment or rare condition that we have to sit in pairs and do this kind of thing, and it only happen a few hours a day, maybe in every 1 or 2 months. So it's not common in a working environment. But the benefit of actually, so if you learn now how pair programming works, you need to learn why actually they mentioned that. They actually recommend that kind of thing because um, building a software actually costs X amount of money. Let's say 10,000 ringgit. Okay, actually maintaining that amount of code that you have written might cost from 30 to 40,000 ringgit actually, and that can be a yearly maintenance cost. If you don't write a correct code from the start, then you will end up with a high cost of maintenance of that code. Because why? The code will be full of bugs and problems that you was not aware of that when you was writing the code in the first place. Did I make myself clear here?
Yeah.
Perfect. Good. So, okay. Now I would like to take you here. So I believe, can you recognize anything in the screen? Any of the pictures in the screen?
Yeah, the RAM picture.
The RAM. Okay, perfect. So I think you already know that this could be a desktop RAM, and this typically is a laptop RAM, right?
Yeah.
Okay, good. So I would take you now to an image that describe. No. Okay. So here, this is the concept that I just introduced to you a while ago. So if this is the RAM that you can see on the screen here, the RAM is divided into two parts. One is the address here, and the address here is not using 123. It's actually using, it is a form of 123, but this is using a binary numbers. That's why you only see 1 or 0. But we don't need to care too much about that. We just need to understand two things. There is a address part, and there is a part where we can store the information. And of course, everything stored inside the computer is always ones and zeros. So did you hear about the word transistor before?
Yeah, transistor.
Yeah. Did you study it in details or something?
I did study, but I'm not quite really, but I know a bit of basic. But
okay, we need only the basic. We don't need to go into details. So everything inside the computer is actually kind of transistor, but it's a very micro-sized transistor. It's not a bigger size that we see in electronic circuits in this shape. Normally, a transistor is kind of 3 parts, and it's made of silicon inside. And we don't care about too much about that. We just need to know that the transistor can only understand on or off.
Okay.
Okay. So on means 1, off means 0. That's why everything stored inside the memory, inside the processing, inside the CPU, internally is only ones and zeros. Okay? This is what we need to know only from that part. I think you have seen that thing before.
Yeah.
So that is the CPU, right? So it has millions of small transistors.
Okay.
Yes. Okay. So now we move. I just previous class, I already explained to you past about programming language and the low level and high level languages. Can you still recall anything from that, or I need to go fast on that?
You can go fast.
Okay. So a low level language, examples of a low level language, something is called machine code. Okay. And something called assembly language. Let me show you how they look like. Okay, here, yeah, here is an example. So an example of, like we said, low level language is very close to the machine. this is the languages that have been used 40 or 50 years ago since they started making the computers. It is hardly used now, and it's not so easy to write in that languages. If you only work with programming something called embedded systems, okay,
Okay.
you might need to learn something about the assembly. Other than that, maybe you pass your whole life as a programmer and you don't need to learn assembly or deal with assembly. So I would like you, we have written a little bit of Python. Python is a high level language that is simply for the human, simple for the human to understand. And if you can look here, I'm reserving a place in the memory that's called sum. I am adding two numbers there, 5 plus 2. So it means that in the memory, the place that is called sum, it will be having 7 inside, which is the sum of a 5 plus 2. Okay. If I
Okay.
want to execute or write that line of Python in assembly language, I will need 3 commands like that. And please have a look. The commands does not even have the 5 and the 2 that I need to add. No, LDA means go to the memory address in the RAM that is called 8 and load whatever inside the memory address that's called 8 in the processor. So it will, inside the processor, the CPU that we have seen just now, there is
Okay.
internal memory spaces for storage, for temporary storage of the information that we are doing some processing on it. Okay. So bear in mind that what I am explaining now is just for the sake of understanding how beautiful is a high level languages. You don't need really to program in assembly or to really understand details about it. Just to know that it is a kind of ni'mat to have a high level language compared to the low level language. So now LDA telling go to address 8, get whatever inside, put it in the CPU.
Okay.
Okay. And then the second command add add9. He is telling go to the address number 9 and get whatever inside it and add whatever you find inside to whatever you stored in the previous command and you store it in the CPU. So he will get whatever in 9 and add it to whatever he finds on the 8. Okay.
Okay.
And STA is telling, okay, add store the addition of whatever you find in 9 and whatever you find in 8 in the address that is called 10. So he will get whatever he find here and here, add them in the processor using the CPU, and store the result here. So actually, these 3 lines is equivalent to that. What do you think is more clear, the assembly language or the Python?
Item.
So you see now how easy is that. Of course,
Yeah.
Python will look terrific, and I mean, look, oh, it's strange and it's not so easy to handle. But if you want to write equivalent code in just for adding 2
Certainly.
numbers, it's a long story, I tell you.
Yeah.
And
Yeah.
I am already telling you now. You see here, he doesn't say we have a label called sum here. He actually have to deal directly with the addresses of the memory, and that is troublesome in itself. Okay.
Uh-huh.
So another step before we leave that part, every line of assembly code can be translated into ones and zero of a machine code. So this line LDA8 will be translated to ones and zeros in a binary setup to be able to be stored. So this is a command that the machine or the computer internally understand. He only understand ones and zeros. So even every
Yeah.
line that we write of a code have been translated to that. Okay. So then how the computer can actually understand our Python? He needs a translator. So that translator looks like, let me share with you. He looks like that. I believe maybe you can recall back the image from last time. Can you? So even if you don't, it's quite simple. The point here is that the translator, we said uh, that the computer is dumb. He only understands ones and zeros. So when we write Python, it needs to be translated into ones and zeros using a program called translator. Okay, translator, there is two types of translators that we talk about, and as you see, Python enter from here, ones and zeros comes out from here. Okay, so that translator in our case is is stored, or we have it in Readability. You don't have it installed on the computer at the moment. We use the Readability website, and he do the translation for us, and he run the program for us. Okay, so the translator have actually two kind of yeah. Okay, now let me see here. Yeah. I want to, yeah. So Python actually use a translator called interpreter. Okay, and so this interpreter, like I told you a while ago, he takes the code of Python and he translates it internally to ones and zeros that can be understood by the computer internally.
Yeah.
Okay, so there is another type of translators. They are called compilers. These compilers can work with other languages. What kind of language? We have, for example, C++. Okay, if you dealt with C#, VB.NET, these all use compilers. This compiler, it is actually the same job at the end. It take whatever language you put, and it output ones and zeros that the computer can understand. So either interpreter or even compiler, both do the same job. Compilers work with certain languages, interpreter work with other languages, and that's it. That's what you need to know at the moment. Okay, good. So, okay, let me share with you a few things so that we don't, or never mind, we can return back to. Okay, did you hear the word algorithm before?
Yeah.
Okay, so do you know what is the difference between algorithm and a program?
I don't know how to say.
Okay, so let me try to recap here. Actually, the algorithm is a set of precise instructions, but it can be the form of a text, or it can be a form of a drawing like that, and it is not necessarily related to computing or even a programming language. So you can write an algorithm in an simple English language, or even draw a text like that. So we still can call it algorithm. The algorithm, I would say, if you buy something from IKEA, so it typically comes with a manual inside, and the manual will give you a detailed instructions how to assemble the part that come, the part of furniture, either a table or even a chair. So this set of instruction, of detailed instructions, we can call it as an algorithm. It is represented by both text and drawings, and it will, if you follow the algorithm correctly, and if the algorithm is designed in a proper way, anybody who reads the instructions should be able to reach the target, which is assembling a chair or even a table, or even we can consider cooking some cakes as also an algorithm. So if you see some of the magazines in the market, you can buy it, you follow the instructions given, you're able to reach up to making a kind of dish. So this is also called an algorithm. Okay, but now we look what is the difference between algorithm and a program. So a program is also a set of instructions, but it is expressed in a programming language. It means that you cannot write it in a normal English. You have to write it in a Python or C++ or a Java or whatsoever. Okay, so that's the difference. Now, yes, and we said before, Python use interpreter. Okay, and let me have a look here. We talk about pair programming. We talk about hello world. Let me see here. Okay. So, okay. I want you to have a look here. This is a 2 lines of code. These 2 lines of code, the first line, he is telling to the computer, please reserve a place in the memory and call it a user, and put inside that place text. Okay, that text actually how we as a programmer recognize it and how the computer recognize it. Anything between double quotation is called text.
Okay.
So he put a text in a place of memory, and then he go to print something. This something have 2 parts, a static part and a dynamic part. Why I say dynamic? Because user actually is a stored place on memory, and it is a variable. It means that you one time you can put Claude, another time you couldn't put Ahmed, or another third time you can put Muzaffar. Whatever inside it, the computer will just go to the memory and find whatever inside the place in the memory that is called user. It will get it out and display it on the screen. So if we quickly go here in the code, so I put here user. Can you see my screen?
Yeah.
Good. So I will put here user. I put Muzaffar like that, and then I will tell him print hello Muzaffar. So I print hello, and then I will use user like that. Okay. But then can you see the output of the screen?
Yes.
Why do you think we put the effort to actually put that part as a static part? Means that it will print it as it is, but this part we put it dynamic. So the key here, when you use variables, you make your programs dynamic in somehow, or smart somehow. Because if I say, if I change, okay, assume that you have a few lines like that. So I have 3 lines. Okay, I have 3 lines like that. Okay, and that 3 line actually is all of them using whatever inside user. So can you imagine now if I print like that? So do you see how many lines we are able to use whatever inside the variable user, right? So if I change here, so a user, I change his name. Okay, and then the 3 lines printed exactly whatever inside user. So if I didn't put if I didn't use a user variable, you will find me, if I want to change, I have to go every line and change, oh, hello, Sammy. And then here, hi, Sammy. And then here, morning, Sammy. So did you notice? So instead of making trouble to myself that I have to fix whatever need to be printed, I make it smart, and I only need to change it in one place. And he will make use of that change automatically for me. And if I put 10 lines of that kind of code, I no need to change the 10 line. I already make it smart enough that it will go to whatever I put inside here, and it will get it and print it. Does this make sense to you?
Yeah.
Okay, perfect. Another simple example. So before we move from here, see. Okay, you see the value of x is 200, right?
Yeah.
Okay, I want to share with you that I can write here 10 lines, but I will not just, I will put here and just a few lines here. Okay, can you have a look here?
Yeah.
So the point here from what I'm doing, remove Sammy at all, we don't need it. X equal 200. So just here, I just able to print. Can you see the output here?
Yeah.
And also, even if I just want to put X like that, so if I change the value of X and run, so it will always print the value of X as it is. If I change it here to 2, so it is smart enough to always get whatever value inside the memory and print it for me. Is that concept clear to you?
Yeah.
That is great. That is great. Actually, you are. I can say that you have a potential of becoming a good programmer, because I have seen students that take 3 or 4 lessons just to understand that simple concept. So it's good, actually. It's very excellent and good. We progressed so far. Actually, a good progress. So I think we should summarize, and we should think how we can plan our future lessons. Do you think the lesson is condensed? I need to slow down a bit, or it is okay?
It is okay for me.
Okay, that's great. And then you have also to tell me, would you like to have longer lessons? Means that like 1 hour and a half or 2 hours, or is enough 1 hour?
Yes.
Okay.
I think longer is better.
Okay, good. So today we can stick with 1 hour, and we can plan our next lessons into 1 hour and a half or 2 hours based on your saturation. So once you are saturated, you can tell me, oh, stop, I cannot take it anymore. Okay?
Okay.
Okay, good. So one thing before we close, I need to share with you every class. I will share with you the slides and the videos that we have in every class. So let me please share with you. Give me a while, please. So, okay. Here. So as you can see here, I will give you one address, one URL, where you are able to find all your class recordings. Typically, class recording is only available after 36 hours. Why I need that? Because I need to convert the videos, upload it to YouTube, and then make links here. Okay, so all the videos you can find it into separate parts. If we take 2 hours, it means that you find 2 parts, video 1 and video 2. And this is a summary of every normally I make for every video. And so okay, here, like you see here, okay. So the point here that I always upload the slides that I teach you in a Google Drive, and I put for you the link.
Okay.
I put for you the link. Let me see here. I put for you the link. Let me see. Yeah. So I put for you the link also on the URL that I shared with you. Okay. So that is always the case in every class. So the URL will be always the same for you. It is just that every class I will add, okay, this is class intro, this is class 2, and then I will put the date inside it here. And there you'll find your homework exercise and any slides that you can open and learn from it. Okay. So typically today, maybe the exercise will be slightly simple. It is fine if you cannot understand the exercise or you face difficulty in it. We can always discuss it on the next class. Okay.
Okay.
Okay. So tell me what is the preferred time for you to have